Alright, so in Chemistry 30 today we're going to look at the functional group ketones. Ketones, not ketones, not ketones, ketones. Alright, a ketone is an organic compound in which the carbon of the carbonyl group, we just talked about that, is bonded to two other carbons. If you remember, the carbonyl group was always at the end of the chain. So here's from yesterday, aldehydes and stuff like that. Go back a little bit here. Okay, carbonyl group, you see at the end of the chain. See, end of the carbon chain. So if we pop back here to, where are we? Awesome. So it's in the middle of the chain, okay? It's within the carbon chain instead of at the end. Okay. Ketones have the general formula where R and R prime represent carbon chains or rings bonded to the functional group. So just remember that this part in the middle here, the part that makes it a ketone, doubly bonded to an oxygen, is in the middle of a chain. So this can't be a hydrogen or an OH or an NH2 or anything like that. It's got to be a carbon, 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 and one of the carbons that's sandwiched in there is double bonded to an O. The carbon atoms on either side of the carbonyl group are bonded to the other atoms. So yeah, carbon here can have whatever they want on there, but this part in the middle is what makes a ketone a ketone. When we name ketones, and here's an example of a couple ketone structures. Okay, so you have this carbonyl right here, the C doubly bonded to the O, but it's in between two other carbons. And there can be longer chains, of course. But we change the E at the end of the alkane name to -one. Okay, O-N-E. So ketone is going to be O-N-E. And we include the number before the name to indicate the position. So the number indicates the position of the ketone group. So if we look at these examples here, we have 1, 2, 3 carbons, and so that's meth-F-prop, right? So it's propane, but instead of propane, we take off the E and add the -one. So it's propanone. And it's on the second carbon, so we add the 2 there, 2-propanone. Even though technically, because it's a ketone, when you see the -one, you know there's only one option. Because there's only 3 carbons, it has to be in the middle one. And the little note here is that even though there is only one option in this particular compound, we put the 2 on for clarity. So just so there's no guessing, if you just say propanone, it's like, okay, well, you could figure that out. But 2-propanone, it just kind of automatically your mind goes to, okay, 2 is second carbon. Okay. So you may see it just written as propanone, but technically the IUPAC name, the naming system, has the 2 in front of there. And the common name is acetone. And someone asked me the other day, do we need to memorize all the common names? You don't need to. If you jot that down on your study sheet or whatever, cue card, that would be a good idea. If you can memorize some of the common ones, that would be even better. So there's good, better, best. You do need to know the IUPAC naming system. Other than that, you don't need to memorize the common names, but if you can, you should. So this one, we have 1, 2, 3, 4 carbons, and so that's meth-F-prop-bute, right? Butane, but we have a ketone group here, so it's butanone, and we're on the second carbon, 2. Now again, there really is only one option for this, because if this ketone group was over here, that's still the second one, right? So when you get into longer chains, those names or the numbers mean a lot more, but we'll still do that for clarity, okay? Any questions there? Alright, properties, uses of ketones. Ketones and aldehydes share many chemical physical properties because of their similar structures. So ketones and aldehydes are similar in their properties. Ketones are polar and less reactive than aldehydes. For this reason, they are popular solvents. Okay, so polar molecules, less reactive. You can use them to clean lots of different things. So solvents, paints, varnishes, glues, lacquers. So lacquers and varnishes are similar. Kind of a sealing, a finish to wood products, things like that. So also like aldehydes, they cannot form hydrogen bonds with each other. So that's similar, but they can with water. So they are somewhat soluble in water. And acetone is completely miscible with water. So that means it mixes in fully and completely. Okay, so here are some examples of ketones. Why don't you just take a minute to look at the carbon chains, look at the position of the ketone group, and name these simple ketones. Okay, just take a minute and write down your guess for the name, just judging from the notes that you just had. Okay, so let's see if you got this right. Let's see, 1, 2, 3, 4, 5 carbons, so that's where the penta comes from. And we take the E off and we add the one because of this ketone group. And 1, 2, 3, the smallest number in counting to this carbon would be 3. So 3-pentanone. How many of you had that for answer? Got it? Awesome. All right, let's see what this answer is. 3-octanone. 1, 2, 3, 4, 5, 6, 7, 8. That's where the octa comes from. It's a ketone, so we've got the one. And we wouldn't count 1, 2, 3, 4, 5, 6. We wouldn't say 6-octanone, because remember, we want to keep those numbers as low as possible. So we count from the end of the chain that gives us this lowest number. So this is 1, 2, 3-octanone. So why don't you have your try your hand at drawing these ketones. This is 3-hexanone and 4-octanone. Alright, so I'll reveal the structures here for these ketones. Let's see if you agree with this here. 3-hexanone. So we've got 1, 2, 3, 4, 5, 6. We should have 6 listed there, and on the third one we should have our ketone group. 4-octanone. You have 8 carbons, and on the fourth one, your octanone group. Please remember you have the H3s on the ends, right, and the H2s in the middle. Just make sure you count around carbon, 1, 2, 3, 4 bonds each, and this carbon is going to have 1 bond here to this carbon, 1 bond to this carbon, and then it needs 2 more hydrogens. That's how you keep track of that. Okay, any questions on that? Alright, next group we're going to study is carboxylic acids. Carboxylic acids, carb. Okay, so carbo, right, we've got carbon in there. Oxy. Carboxylic acids. Acids. Okay, so a carboxylic acid is an organic compound that has a carboxyl group, a carbonyl group that is bonded to a hydroxyl group. So it's carbonyl and hydroxyl. So this C doubly bonded to O, as we've just learned, is the carbonyl group. This, you know, is an alcohol group or a hydroxyl functional group. And so the mixture of them is carboxylic. Okay. So how do we name these carboxylic acids? Although they have many common names, and there will be a lot of common names, the formal name is used by changing the ane at the end of the alkane to anoic acid. Okay, so these are all acidic. Very acidic. I wonder why that would be. Why do you think these would be very acidic, or these would form acids? What do we know about acids? What do acids generally do in solution? Anyone know? Remember? We're going to talk a lot about acids and bases in this course later on. Okay, but what you should know about acids is that they release hydrogen or cause excess amounts of hydrogen ions in solution. And so it appears that perhaps this hydrogen may get lost very easily, or be able to be donated to the water molecules to form an acidic solution. So that one's just kind of hanging right out there, isn't it? Anyway, so we'll change that name to anoic acid. So one carbon is methane, and so we'll take off the end, and really we don't really take off the whole ANE because AN is still on there, but they add it here. So methanoic acid, and its common name is formic acid. Do you mean like this? Are you saying, is this the same thing if it's like this? Yes, yeah. But if we're showing all the bonds here, they'll want to show that bond there as well. So yeah, it's a ketone group here, carbonyl group, and then your hydroxyl group. Yeah, it's the same. Yeah, yeah. What you don't want to do is you want to draw this. You just can't do that because this O is not bonded to the other O. See, they're bonded to the carbon, so just make sure you don't do that. If you are going to write it, then what you do is you write the COOH, but these are not bonded to each other. So how this is written like this, but it's not. You have to understand that these O's are not bonded to each other. Okay, so just make sure you get these notes before you take off here. This is the end of the lesson, but and so this would be ethanoic acid because of the two carbons, and here is your carboxyl group.